Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem number 128 LeetCode, longest consecutive sequence. So the problem statement says that given an unsorted array of integers, nums, return the length of the longest consecutive elements sequence. Alright, so for example, we can see nums array is given and we have to find the length of the longest consecutive elements sequence. So the longest consecutive element sequence is 1 2 3 4. So basically the question is stating that if we are given an array and from all these elements we have to find the longest longest sequence of the consecutive elements. All right, we have to pick elements from this nums array and we have to form a sequence, and the sequence which will be longest, we will return the length of the longest sequence. All right, so from this array we can see, if we form a number line, let's say, so it is given 100, so let's say 100 is here. All right, and next is 4, so 4 is before 100, 4 will be here. Next is 200, so 200 will be here. Now 1 will be here. Next is 3 will be just before 4, and next is 2. So if we check the sequences, we can see that one sequence we are getting this, next is we are getting this, next is this. So we have to return the length of the longest sequence which can be formed. So here we can see the length is 4. Alright, similarly in the other examples we can also see we have to just return the length of the longest consecutive elements sequence, and we have to write an algorithm that runs in big O of n time. Alright, so what can be the approach which can come into our mind? So after seeing this, we have to return the consecutive element sequence. So first approach which comes into our mind is just to sort the array. All right, so let's say if any array's nums array is given, and after sorting it comes, let's say 1 1 1 2 2 2 3 3 3 4 4 4 100 100. All right, suppose after sorting nums array it comes this, and then we can easily found longest consecutive sequence. We will start from here and we will track the previous smaller element. So now the previous smaller element in the starting is int min, and now we have reached this, so we have found a new element. So we can say that our previous smaller has now become 1. Now we will move here, 1 is equal to the previous smaller, nothing happens. Now we reached the element 2, we can see that our previous smaller was 1. So yes, from here we can choose this subsequence, choose the form a sequence 1 2. All right, so I mean, by keeping track of the previous smaller number, that is 1 here, and moving ahead, we can just check if we are getting a new element and it's equal to the 1 greater the previous smaller. So we can say that yes, if a new element, suppose 2, is greater than just is just 1 greater than the previous smaller, that is 1, so we can say we can add this in our sequence. Similarly we will see 2, we will do nothing. Then we found a new element which is greater than the previous smaller, but it's just 1 greater, so we can add this. Similarly we will move ahead, we will found 4. All right, so again we will add this to our sequence, we will move ahead. Next time the new element which we found is greater than the previous smaller element, but it's not just one greater than the previous smaller element, because our question says consecutive sequence. All right, you have to form the longest consecutive. So 100 is not just one greater than the previous smaller. If we have 5 here, then we can see we can add 5. So from here we will reset our count. Let's say our count is count was 4 and we store a maximum count. So now our count will reset to 1 again. Alright, so we will form a new sequence 100. Now moving ahead. Alright, now we will see this 200, which is not also, which cannot also come into this sequence. So we'll form again a new sequence. So this way, by resetting our count and storing a maximum variable and just previous keeping track of the previous smaller element, we can just check how we can just check the length of the longest consecutive element. All right, but after sorting this for sorting takes big O of n log n time complexity. So we cannot take this, we cannot afford this time complexity, because here it is written we have to write an algorithm that runs in big O of n time. So what we can do next, which approach which comes into our mind, is we can use set. All right, so suppose this example is given 100 for 200, 100 for 200, 132, 132 is given. Suppose we store this into set. Alright, so if we take ordered set, inserting element in an ordered set takes log n time complexity, and storing all the n elements will take n log n. So again this will be n log n time complexity, but we have to do this in big O of n. So what we can do, we can just use unordered set. So after using unordered set, this will store all the elements, all the unique elements. It will remove the duplicate elements because we are using unordered set. So this will store all the unique elements into the set. Now what we can do, we, according to this question, what sequence is coming, what possible sequences are coming from seeing this nums array, we can see one sequence is 1 2 3 4, another is 100, and another sequence we can get is 200. All right, now what we can do, we can check if the element is the starting point. Suppose in this array the starting point is 1, starting point is 100, and starting point is 200. So if the element is starting point, we can run a while loop and go and check if the current element plus 1, suppose our, if 1 is a starting point, if we are on 1, we find starting element, 1 is the starting element. Now we can say that x is equals to 1, let's say, and now we can go and keep finding x plus 1. Alright, we will go and find x plus 1, that is 2, and if this will be in our unordered set, then we can say that yes, it's a part of sequence and we will increase our count. Similarly, if x plus 1 is found, we can just go and again find x plus plus element. This will be 3. Alright, so we will find 3 also. If it again come, we will increase our count in the sequence. Next we will found 4. 4 is also there. Next we will found 5. 5 is not there, we will break. So this way, I will tell you also, I will try run also. So we are, suppose we are at first we are at our element 100. Alright, so we will check is this the starting element, and how we will check this is a starting element or not. We can just look for the element before it. So if 99 is present in this nums array, so it means it's not the starting element. Then maybe the starting element can be 99. So is 99 in this nums array? No, it's not in the nums array. And we all know finding any element in an ordered set, in the best and average case, this takes big O of 1 time complexity, and in the worst case, I mean extreme worst case, but that's very rare. When collision occurs, when extreme bad collision occurs, then can go to big O of n. But for now, we will, according to the question constraints, it is saying that we have to do this in big O of n, so we can assume also that this will not the collisions are not there, so we can say that we can just go and find 99 in the nums array using an ordered set find function. This will take big O of 1 complexity. So 99 is there? No, it's not there. So we can say that yes, 100 is our starting element. So now we can just keep finding. So our x will be, let's say this will be x, and we will keep finding x plus plus. So x plus plus, that is 101, and we can keep track also, such that let's say maximum count and current count. Alright, so maximum count, let's say this is int min, as we always store int min, and int min, and current will be, let's say if we are at any element, we can say that current is 1 now. And if we find x plus plus, that is 101, is this in the array? No, it's not in the array. So we will say that it's not in the array, and just move and update our maximum count. Maximum count will be 1. Alright, now we will move ahead. We are at 4 now. Now first of all, we will check, is this the starting element? So how can we check starting element? We will go and find 4 minus 1, that is 3. Is 3 in the starting element? Yes. Is 3 in the array? Yes, 3 is in the array. So 4 is not the starting element. So we will move ahead. We will not check this. Now 200. For it, we will check, is this the starting element? Is 199 in the nums array? No, it's not in the nums array. So we can say yes, it is the starting element. Alright, so now we can go and we can just find our x will be 200, and we will just find x plus plus. So we will find 201. Is this in the nums array? No. So we will break now, and we will update our current will be 1. Alright, and we will update our current and max count. Alright, now we will move ahead. Now we will be at 1. So for checking this is the starting element, we will just reduce it by 1. We will find 0. Is 0 in this nums array? No, 0 is not in the nums array. It means that 1 is our starting element, and now we can just assume this as x, and we can go just find x plus plus, that is 1. That is 1 plus 1, 2, and we can if we find 2, so yes, 2 is in the nums array. So we will increase our count by 1. So this will be 2 now, because now we can form a sequence 1 and 2. Now again, if we find it, we will increase x plus plus. We will keep finding until we don't find. Alright, so now we will find 3. So again, 3 is also in this nums array, so our current count will be increased. Now we will keep finding. Now again x plus plus, this will be 4. Now we will find 4. Yes, 4 is also in this nums array, so 4 will be also this in the part of the sequence. So current count will be updated by 4. Now again we will increase. We will find 5. Now 5 is not in the nums array, so we will break here. We will end our loop, and we will just update our maximum count. This will be 4 now, and we will move our I pointer ahead. Now we are at 3. So is 3 the starting point? We will go and find 2. If 2 is in the nums array, it means 3 is not the starting of a sequence. So we will move ahead. Now 2. For 2 we will find 1, and yes, 1 is the nums array, so it means that 2 is also not the starting of a sequence. So we will just move ahead. Now our iteration will be completed. So at last we will just return our maximum count, that is 4, and 4 will be our answer. So we can see 4 is our answer. So this was the dry run intuition and the logic also. We will just use an unordered set that will help us find elements in big O of one time complexity, and for we are and we can see that we are just iterating our I loop, and we are just keep finding element if it's a part of sequence. So this will just take big O of 2n time complexity, because we will see in the we while implementing also. Why big O of 2n? Because no element is visiting more than twice. Alright, so this will be our time complexity, and for using the extra space for storing all the elements in an unordered set, this will take big O of n space complexity. Alright, so now let me implement this. First of all, I will declare the size of the nums array. This will be nums.size, and we are using an ordered set. Unordered set int as st. Now first of all, we will move all the elements into the unordered set. Nums st dot insert c. Now we will first of all, what I said, we will store our answer. Our answer can be, let's say, max count. Max count in the initial, it will be min, int min, and our current count, let's say the same element, we can say this is 1. Now iterating all the elements into the set st. First of all, I will check, is this the starting element of a sequence? So how can I check? If the number which is there, if we find in the set, if we find one less than the element in the set, if we find it, so we will do nothing, we will just move. If we did not find, so this will return st.end. all right, so this means if st.find c-1 is equals to st.end, this means we haven't found. All right, this means this function st.find c-1 is equals to st.end, this means not found. All right, not found. Or yes, this is the starting. Yes, starting. All right, now if this is the starting, so what I said, I will assume this as x, this c as x, and I can maintain, and I have current count also, and I will just go and find the next element just greater than it, st.find c+1, and if I find it, all right, found, next greater by +1. all right, so if I found this, so what I will do, I will just go and try to find next. I will just increase x. All right, so this was x. All right, this was we have to find c plus 1. All right, so if we find x, we will not try to find x plus plus. All right, and if we find, we also increase our current count, this will also increase. All right, now after finding all the consecutive elements, I will just update my max count. This max count will be nothing but max of the max count and the current count which we have just found, and at last we'll just return our max count. And yes, we can say that in the constraint it is given that nums of length can be 0. So if nums of length is 0, so we can first run it and then check. So st.end, here I should write st.end. So in this case, I'm saying that length can be 0 also. So if there is no element, if there is no element in the array, so how it will iterate? So it will just at last return the max count, and this will be int min. So I should write edge case also that if n is equals to 0, we should return 0 in this case. All right, and now it will find. And yes, we can say that if we can also store our max count as 1 also, because at max if there is one element in the array, so we can say that longest consecutive sequence, the minimum can be 1 containing that element only. So we can say that int min can also be 1. Now if I submit this question, this code, let's check if we are able to pass. So there is a problem in the case 91473. This output is 9, expected was 7. So let's check if we are missing any edge cases. So what I did, that I declared an ordered set, and I stored all the numbers in the set, and then I created a max count, that is 1 for now. Current count is 1 for now, and iterating in the set. If first of all I will check, is this the starting element of a sequence. So I will found that if c minus 1 I find, and if I didn't found, this will return st.end iterator. So if I didn't found, we can say that this is the starting element. So now if this is the starting, so I will just say that this c is our, now we have to find c plus 1. So x, let's say x is c plus 1, and we will keep finding x plus plus. So first of all I will find x, st.find x is not equal to st.end. This means we have found next greater element by 1 plus 1, that is x. So if we find, I am increasing the current count as plus current count by 1, and also going to find this. All right, and then I am just updating my max count, and yes, I am not resetting my current count. So maybe I should declare this current count inside only. All right, why should I declare outside? Now if I submit this, and let's check if we are able to pass the yes, we are able to pass all the test cases and we have solved this problem now. So if I talk about the time and space complexity, I've told you earlier also, time complexity is just big O of n, because we are using one for loop first inserting into set and another for loop, and this inside while loop we can see that we are just this while loop is finding a we can say a path of a sequence. So and this for loop, if this and this for loop, this if condition is written also. So if it's the starting element, then we are only iterating to it. All right, and if it's not the starting element, we are just leaving it. We are not iterating into it. So we can say at max any element in the array, we can see from here also, any element in the array, we are just iterating only twice. If this is the starting element, 100 is the starting, then we are iterating all the elements of 100. So this is once. Now next here, this is not the, we will leave it. This is starting, you will try. This is once, running once. Next one is there, so we are just checking 2 also, we are checking 3 also, we are checking 4 also. Next 3 is there, this is not the starting, we will leave it. This is not the starting, we will leave it. So you can see that at max we are visiting any element twice. So this for loop and inside while loop, overall this is taking big O of 2n. So at max we can say that our time complexity approximately is big O of n, and space complexity due to this unordered set, we can say that this is big O of n. Alright, so yes, this was all about this problem. Thanks for watching. See you in the next video. Till then, keep learning and keep upgrading yourself.